Hey, hello everyone. Welcome to this new session of the Fabric AI Hack Together series. I'm Ismael Mejia. I'm a senior cloud advocate at Microsoft. I work with the Microsoft Developer Relations team. Let me introduce Amir.
Hello, everyone. Nice to meet you all. I'm Amir Jafari. I'm a senior product manager at Microsoft Fabric Data Science team.
Yeah, we're really happy to have Amir here because he is one of the persons who is key for the examples that you learn with and you play with at Fabric. He's basically the person in charge of all these samples that are ready to use in the Fabric interface. Anything you want to tell us about these samples, Amir? Or?
Yeah, please always, we're more than welcome to hear your feedback, comments. Please send it our way. We're always striving to improve our samples.
Yeah, definitely. And today we are going to talk about a different use case, let's say. Like in this series, we have seen quite different cases of AI use or machine learning also. Like we had this Serengeti kind of use case, and the last time we had this RAG and more LLM-oriented use case. And now we are going to go with the classical machine learning example where we are going to create a model from scratch and evaluate it and clean the data in advance, all the classical process of machine learning. And what is more interesting here is that these use cases are really, let's say, real life kind of use case. No? We're going to talk about reducing churn, like not losing our clients, our customers in business. That's something that we can easily justify, like business-wise, let's say. But before we start, let's not forget that, we are running this series since then, February 15th, where this is the third week we're running on. And if you haven't registered, this is something you can do. But first, we have this link to our repo. This is the repo for the project. You can take a look at all the links to the previous series there, like the previous sessions, that if you miss some of those. And I forgot to say, if you participate in this program, you will be able to win prizes, and there's a prize with cash. And also, you will be able to join the Fabric conference. You will get an invite to visit the Fabric conference. This will happen at the end of the month in Las Vegas. This is a great opportunity to meet meet and learn not only from the people creating Fabric, that are all these people in the picture, the PMs, and the responsibles for all of the features of Fabric, but also to meet the community, meet other people, and learn more about the product and the things you can do. Of course, if you register with the code MSCOS, you will have a $100 discount. And this is the first time we have the conference, so I think it's a really interesting time to join, because you can join early the community. And as I said, this is the let's say fourth session of the series, but the third one that is practical. This is the last one when we're showing an example, and you can still register into this. It's quite easy to fill the form, and still there is time to work in your projects that you can submit at the end of March. There will be one more session, I think, next Thursday, where we are going to introduce how to submit your projects. And of course, if you haven't yet used Fabric because you don't have access into the product, one thing you can do is to register with your own M365 account, and you can get a free trial for 60 days. It's quite easy to go, straightforward. You don't need a credit card. Just follow the instructions, and that should be good. So let's go now to the use case that we're going to talk today, the example of churn prediction. And just before that, you probably should, if you haven't gone there, this is the link where you can find the tutorial that we are going to follow. Another way you can find this is through the Fabric use a sample part in the data science workload interface. If you, I hope somebody copies and takes this link in the chat so everybody can join in. But just before that, let's not forget that running this is, this is one example of the data science process that is something Fabric is optimized into, at least the data science experience. So when we are creating a new machine learning project, what we do is we define the project, the kind of problem we have, the need that we are going to solve, let's say. We get the data in, we have to prepare our data sets and clean some columns, maybe split some, prepare what we call features. And once we have these features, we're going to train some machine learning model to try to solve our problem. And finally, and this is key, and this is really important, well, we want to generate predictions from these models. No, it's not just training the model and having something nice, but well, we want to go further with that. No, and well, since we are going to see this in detail, well, let's switch to Amir, who is going to show us, well, the example. We are going to follow along with the notebook. And don't hesitate to ask questions in the chat. And we will also maybe at some point do some stops just to discuss maybe if somebody will have some questions. So let's go in with the demo.
Awesome. Thank you very much, Ismail, for the great introduction. So as Ismail mentioned, we're going to demo use cases about the churn prediction model. This sample or this example is gonna especially focus on churn prediction for bank customers. But let's just take a moment and discuss why this has an important business value. Churn prediction is an important problem in whichever business industry you are, whether it's a bank or like a subscription business. Customers, for whatever reason, are leaving businesses, and for a business to be able to gain insight into customer behavior and what are the reasons that causes customers to leave, would actually provide valuable insight to businesses so they can actually take predictive actions to kind of help keep the customers at the business. So while this example and sample list has been focusing on customer churn prediction for bank, it's easily applicable for any industry. This is just showcasing how you can leverage many of Fabric Data Science features to build your models, which actually bring immense value to your business. As I mentioned, we're going to walk through end-to-end example how to use Fabric features to kind of predict which customers would actually leave the bank. So some of the steps that we're going to take in this sample, we're going to install some custom libraries. We're going to show how you can install some custom libraries. We're going to load the data. We're going to perform some exploratory data analysis, understand some of the data, what is included in data. We're going to train some machine learning models. Explicitly, we're going to train random forest from scikit-learn as well as a LightGBM model. We're going to log all these models and to talk about MLflow and Fabric Autologging feature. At the end, we're going to evaluate and save the best performing machine learning model. And finally, we're going to actually kind of demonstrate all of this using reporting Power BI, because as you probably know, many of the machine learning models that doesn't get to some conclusive outcome is just because they ended at some sort of a training model. But it's also important to take a step further and actually basically translate those machine learning learnings to basically business insights. And that's where this connection between results to reporting in Power BI would be very helpful. So that's about the introduction. First and foremost, one of the things that you need to do, you first need to add a lakehouse to your notebook, and the lakehouse is where you're actually going to store your data. So as you can see, I don't have any lakehouse attached to my notebook, so I'm going to add a lakehouse. If you have already created a lakehouse, you can actually use an existing lakehouse, or you can actually create a new one. In this case, I'm going to create a new lakehouse. I'm going to add it. I need to select the name, so let's like Fabric Hackathon. That's a name I'm going to pick, and it's going to create a lakehouse. It will take a few seconds, and there you go. So the lakehouse is actually showing up here. You can see there is nothing here. The tables, the files are empty because we just created. There is no data or like being attached to the lakehouse. Okay.
There is one thing that maybe is worth to mention is that we have, a lakehouse is in this moment, this lakehouse is associated to this notebook. So everything we do there is going to be stored in that lakehouse. No?
In that lakehouse. Great point, Ismail. Thanks. Okay, so one of the first things, and let me actually minimize this for now so you can have a better view. So one of the first things that we need to know, like, there are some cases in machine learning model that we need to install custom libraries. And now the first question that may come to your mind is, why are we even talking about custom libraries? I'm gonna explain why we need to install custom libraries for this specific use case in a few moments. But there might be a need to install custom libraries. There are two ways to basically install custom libraries. One is you can basically use inline installation capabilities such as like pip or conda to get quickly started. The benefit of this way is that when you install a library, it would be only installed in your specific notebook, so this notebook, and not in your workspace. So if, for example, you say, okay, I'm going to use only this specific library for this specific notebook, and I don't want to have it in my workspace, pip and conda would be like the easy approach. Alternative, you can also create environments and like have a library specifically installed in your entire workspace. So across different notebooks or whoever using in that workspace, they don't need to constantly repeating in installing a library. The library could be installed in a workspace, so anyone who is using that workspace or different notebooks, they can access that.
And
Now,
that is pretty handy. I mean, when you're in a company environment, when we have these kind of approved libraries that everybody knows and uses, so everything is ready in one environment. So
yeah, we can have just, as Smile mentioned, you can have one library, and you won't need like multiple times different people. You know, there could be like, as I mentioned, in this specific notebook, we're going to use like MLflow. It's a relatively popular library, and like many people are going to use it. So you can just install it one time in your workspace, and that's it in one environment, and everyone who's using that environment or that workspace would be able. Now, in this specific notebook, we're going to use MLflow because we're going to look at a smooth. Again, I'm going to talk about why we are installing this specific library in a few minutes. And one other thing that I want to mention is that whenever you're installing a library, your PySpark kernel will be restarted. So the first step that if you want to install a custom library, it has to be your first step, because after that, you're gonna restart your kernel. So let's just do it together. So I'm gonna install we're gonna use pip install to install a library. So as you can see, it's gonna take a few seconds. It's gonna show. It's gonna do because we're gonna do it a live demo, so it's gonna take a few seconds to install, but you can see that it takes like about 7-8 seconds, and it shows how long it's taking. It's pretty quick. Let's just wait.
One thing also worth to mention is sometimes this first run takes a little bit of time because we are running the setup of the behind the scenes infrastructure that in traditional non-managed services would be like a Spark cluster that is getting ready to run our job. So, but it's pretty fast. I mean, 30 seconds to prepare would be too much.
Great point, Smile. It also shows in less than almost 30 seconds in install library. So you're done. Now let's just go into, okay, this is the library that we needed, and I'm going to explain again why we need that. Now let's look into the data. So, okay, our data set is about bank customers leaving or staying with the bank. Our data set contains about like 10,000 customers, and these 10,000 customers are represented with 14 different attributes. As you can see, a sort of glimpse of the sort of our data. There are different attributes like customer ID, the surname, the credit score, which geography they are located. We are especially looking at 3 different countries, France, Spain, and Germany, whether they are male or female, what is their age, how long they have been with the bank, what is their bank account balance, how many of the bank products they're using, whether they have a credit card or not, are they an active member of the bank or not, what is their estimated salary, and this is the most important one, which is like whether they have exited the bank or not. This is basic referring that the churn one. Have they stayed with the bank or they have left the bank? So these are the sort of the attributes that kind of represent. And as I mentioned, the event that define a customer churn is the closing of the bank account, which is represented by this column, which is like exit. So if the exit is 1, it means that the customer has closed the bank account, has left the bank. Looking into data, we have realized out of like a 10,000 customer data points, only around 2,037, which is roughly around 20%, have left the bank. So you can see that 80% have stayed with the bank and 20% have left the bank. While 20% is still a big number, is a big percentage for a business to lose around 20%, you can see that our data set is not balanced. So the 2 classes, which is like existed versus non-existed, or like people who have customers who have stayed with the bank versus who have left the bank, they're not of the same ratio. So that means that we have some sort of a class imbalance issue or concern, and that's usually could be leading to a sort of non-accurate results when you train a machine learning model with class imbalance ratio. So that's and one of the solutions that we have for that. We're gonna basically generate synthetic data, and that's where Smooth is coming into place. So Smooth is basically referred to a synthetic minority oversampling technique, and it is usually used to generate synthetic data. So again, as I mentioned, when we have imbalanced data, one of the problems is that because the 2 classes, exited versus non-exited, they are not of the same size, it would be difficult to effectively learn the decision boundary. As a result, you can use a Smooth to basically create synthetic data, so you kind of have a more balanced data set. Now, I keep saying here that, okay, we're going to install pipes on IMBlearn. I'm going to talk about it in a few minutes. That's the reason. So a smooth is coming through IMBlearn. So when you actually install IMBlearn in step one, you would be able to basically access a smooth through IMBlearn. So we have already installed IMBlearn. Now that means that later on, when we're going to use a smooth, we would be able to access a smooth. And as I mentioned, whenever you install these custom libraries, it's going to restart your kernel. So you want to do that step at the very first step. I'm going to take a moment to pause here. Is there any questions, anything, or shall we continue?
Well, I'm monitoring the chat. I don't see many questions not answered for the moment, so we are good.
Okay, awesome. All right, so so far we actually have sort of installed a custom library, and we explain why we need that. So now we want to download our data set. So we can always define some parameters that, okay, for example, where is our, what is the name of the data file? Okay, it's called like churn.csv. It's a CSV file where it is located. And again, we can also, as I mentioned, our data set has contained around 10,000 data points. So we can also decide, okay, do we want to use like a part of this data for training or not? Like we can decide if false or true. These are parameters that you can define, and you can, like, for your own specific use case, you can even add more parameters or change these. Again, as I mentioned, it's important to add a lakehouse, and we already added here. So we already added here. Now, if I go back here, so we install this one. Now let's run this sample, this cell as well. So again, you can see it's pretty quick because we are doing a live thing. So we make sure, okay, it's less than 4 seconds. Now our data is already in some sort of public blob storage. So now we're going to add our data to our lakehouse. I just want to again go here. You can see that a lakehouse is added. But you see it's kind of empty. There's nothing here. So now I'm going to basically run this one, and we should be able to see that our data is basically added to our lakehouse. So if I think I can refresh this.
I think in that part you only downloaded the file, but you haven't still registered the table.
Yeah.
No?
Okay. Yeah. And so I've downloaded the file and all of that. So another thing that I wanted to mention is that because we want to also show that like it's pretty quick to run your notebook, run your machine learning models on Fabric. I'm also going to run this cell so we can actually record the time it takes to run the notebook. Now, so I actually sort of download data. Now I want to actually read my data from the lakehouse. So we can. Fabric notebooks support both Spark notebooks as well as like Pandas notebooks. So at the moment, it's like Spark notebooks, Spark data. So I'm going to run that one, and then we can be able to see that. We're going to run our this one to get access to our data. It takes, okay, in less than 12 seconds, and you can actually see that, okay, it's successful. Any questions so far?
I just want to mention that you can show the lakehouse view, as you said, and we can see the file because we didn't see that. If you go to files and click not tables because it's not the table, and you do refresh, I think.
Yeah, I need to give you.
No, just down below. Yes, there. Click there, and if you do refresh, that should be appearing there.
You see that the trend is here. Okay.
Yeah. And then afterwards, maybe we will record this into one table, but for the moment, it's just there. And, and we are reading it with the Spark as a data frame, so we can process it. No?
So now we have our data. So for some of you that may be familiar with some sort of machine learning, you can know that sometimes it's easier to kind of deal with Pandas data frames in terms of visualization and sort of processing and stuff. So while our initial data is a Spark data frame, we can easily convert it to a Pandas data frame. So I'm going to run this one to convert our Spark to a Pandas data frame. But again, you can also run all of these on a Spark data frame, but just like for processing and visualization, usually it's easier to deal with Pandas. So now I've also like converted my my Spark data frame to a Pandas data frame. So now the next step is to perform some exploratory data analysis. But before that, I'm going to again take a few seconds to see if there are any questions, anything that you need further discussion.
Is there just a question about the Spark compute? It says, is the Spark compute dynamic, or do we have to set up before you start running the notebook?
It's dynamic. You don't need to set it up.
Yeah, this is self-managed. This is automatic. Of course, the capacity is limited to the capacity you have in your Fabric subscription.
Okay, so far we have installed library. We have got our data in our lakehouse, and actually, like we read our data from our lakehouse, and we converted from the Spark data frame to Pandas data frame. Now we want to basically do some exploratory data analysis, get some insight to our data, what it is contains, missing values, get some statistics. First and foremost, like we need to install some basic libraries, pretty typical visualization libraries that is used in machine learning, Seaborn and Matplot, NumPy and Pandas. So you can actually like do some sort of visualization to get insight to our data. So I'm going to run that. We're going to import these libraries. Bear in mind, another difference is that some of these libraries is already installed in Fabric, so you don't need to kind of install them. So you can just like import those libraries. So we have done that. Now we're going to use display function to get some statistical insight to our data frame. So let me run that one. Okay. So it's taking a few seconds and then we should be able, okay. So now you can see that we get some insight to our data frame, like, okay, what are the columns? 10-year has credit card, estimated salary. It shows the type, the number of unique values that there are, the number of missing values. And so we get some good statistical insight into our data set. Now, as you're familiar, if you're familiar with machine learning, one of the first steps and probably one of the most sort of exhaustive steps is to actually like clean your data and like see what are the missing values and all of that. As for that, we have Data Wrangler embedded in Fabric, which is like a tool that helps you to basically perform some sort of data cleaning. And then it also helps you regenerate the code required to perform that data cleaning. So you can launch Data Wrangler directly from Fabric Notebook. So you can go here, like we have different tabs. You go to the data tab. It says like a transform data frame in Data Wrangler. And then you click on that and it would actually show you the data frame that you have. Data frame, it will support both Pandas and Spark data frame. So as you know that we converted our data frame from Spark to Pandas. So now we have this one and that would be selected. So now we are going to like a Data Wrangler tool. And it basically shows initially some sort of a visualization of your data, the summary and all of that. And you see there are some number of operations here that helps you to kind of perform some data cleaning. It would generate the code and then you can import that code to your notebook and then run the notebook. But it's much easier UI tool that helps you to perform that like that. So first and foremost, for example, I want to drop duplicate rows. So on find and replace, I'm going to click on duplicate rows, and then I'm going to select the columns that I want from which I want to drop duplicate rows. So initially selected all of that, but I want to say like from row number and customer ID, these are the two columns from which I want to drop duplicate rows. So you can see that it's generating the code for that. df drop duplicate across these two columns. So I'm going to like easily apply, and then I can like apply that. Which you can see, okay, it's also show a preview of what happens if you do that like that, and it actually show you a set of operations. So first it's like that one. Now I also want to look at some sort of missing values. So I want to also look at what columns to miss values. So I'm going to do that, and then for that I'm going to select all of the columns. If any column it has missing values, I'm going to apply that one. So you see it easily generate the code, and then I'm also going to click apply to kind of get a preview of that one. And again, you can see that the steps that I'm taking are all shown here. So first I've got the load the data, now duplicating the rows, now dropping duplicate rows, dropping missing values. Now I also want to look at other steps. There could be like some columns that maybe I want to drop. So I'm gonna, for example, go to, again, I can show there are different operations you can do, like from format, you can from formulas and all of that, different operations that you can do. So there are different lists of operations that you can do. So I go to, for instance, I go to schema here. Now I want to drop columns. What columns? I want to say that, okay, row number doesn't seem to be relevant to any machine learning library. Customer ID doesn't seem to be relevant. And also surname. So these are the things that I feel they may not be relevant. So I'm also going to drop those one. So again, I'm going to apply that one, and I'm going to show the preview of here. And this also, if I go here, it also shows the steps that I've taken. Again, I have first loaded the data, I dropped the duplicate rows, I dropped missing values, I dropped columns, and I think that should be enough for example, some initial data cleaning. So the code has, yes.
One thing that is pretty cool, I mean, is that you can, apart, if you don't know the API, well, you can play with these data preparation steps like that. and you see the generated code. So it's useful to learn or just to generate the code, but also, well, you can also see the data distribution quickly. Like you have like an interactive way to see the changes you are doing with the tools. So it's pretty neat.
Yeah. So you could do that. And again, as a machine learning sort of practitioner, data scientist, data cleaning is usually a very difficult step. So you can actually like even try some of these, and then like you can remove that. If you said, okay, like for example, you can say like, I'm going to fill my missing values, and then you're not happy, you can just remove that operation. So far, I think I'm pretty happy with the set of operations that I have done, and then the code is generated. So I can just add to the notebook. And in a few seconds, if I go back, you can see that this is again says like code generated by Data Wrangler for Pandas data frame. And I sort of put all of those in a function and call like, so, okay, duplicate rows in columns, drop duplicate rows, drop rows with missing values across all columns, and drop columns. And these are the columns. So all of that.
I just want to mention one more thing. I mean, even if you are not using Fabric, you can play with Data Wrangler today because there is a Visual Studio Code extension, so you can install it in Visual Studio Code, get familiar with how it works. So.
Yeah, and let me just tell you, Data Wrangler is a great tool. Many of our customers actually love Data Wrangler. It has been very helpful, and it has like expedite the whole process of data cleaning for them. You don't need to worry about like writing the code. It will generate the code and can just easily import that code to your Fabric notebook. Okay, so I've done that. So now let's just like run it. Okay, we pretty quickly. Now, if you remember at the beginning, I mentioned that, okay, you can define some parameters. If I go up here, it's like, okay, how many of your rows or samples you want to use for training. So you can decide, okay, I want to use all of it, part of it, and all of that. So this actually tells you, if I go down again here, it tells you that, okay, if you want to use some of your samples, some of your data points for training or not. Okay, so far, again, we use Data Wrangler to perform some initial data cleaning. We have dropped some columns. We have, drop rows with missing values and duplicates and all of that. Now we go to next step, which is like we want to explore, do some exploratory data analysis and like get some insight to our data and all of that. So before that, first of all, I just want to get an insight that, okay, what are my categorical features? What are my numerical features? And what is the target basically column that I want to predict? So I'm going to run that one. So exited is basically the column that I want to predict. So I'm doing all of these model. I'm training a model to kind of predict which customers would leave the bank or not. So exited is basically my target attribute. Geography, gender is basically my categorical attributes, and these are also my numerical. So I can just get some sense of different attributes or features that I have. Now I want to go to some visualization. As I mentioned, we imported like Seaborn and Matplot. So I want to basically get some sort of insight into like minimum, maximum, the first and third quartile, and median of my numerical features using boxplot. So I'm going to run this, and it would actually show me, okay, so for different features, for credit score, age, tenure, estimated salary, and balance. So for instance, I can see that, like for example, the boxplot for my credit score, I can say the median is around like say 650. I can look at like for age, I can see that the median of age is around, let's say like 38 mid 30s. How many years the customers have been banked. The tenure, like the median is like around like 5 years. So I can get some insight, okay, about different features. This is actually helpful because I can also, for instance, like for age, I can see that, okay, there seems some outliers around like 90, but, in some machine learning algorithms, you might say that, okay, maybe that's an outlier, but, now it's because it's an age thing, it's hard. You might not necessarily consider that as an outlier because there could be actually bank customers who are like at 90. So you may not consider that necessarily as an outlier. So it actually gives you some good insight about your data. Now, next step, I want to actually look at the distribution of exited and non-exited customers across my categorical attributes. So I'm going to run this cell, and you see it's pretty quick. It takes less than 2 seconds. You can also get one thing that I actually personally love. You can actually get the date and like the exact time that you have been running. So February 27th at 9:30 a.m. Pacific Standard. So it actually helps me to remember like when exactly I ran this on. All right, so now we can get some sort of a distribution of categorical. So I can, for example, for exited versus non-exited customers. So I can see that, for example, out of the 3 countries that we have, Spain actually has the lowest number of customers who are leaving. So the brown which is the reason why is like customers who have left the bank. So I can see that Spain has lowest number of customers who have left the bank. I can also look at, for example, here that, for example, active and non-active. So the ones that are non-active seems to have a higher churn rate. So the brown is representing where customers have left, 0 is representing those who are non-active. So the non-active seems to be leaving the bank more. And I can also look at, for example, the number of products that the customers are using. I can see that, for example, the customers who are basically using, for example, more, like, for example, customers who are using more than one of the bank products have a lower, for example, churn rate than, for example, those that are using just a single product. So I can get some insight that would probably help me to determine like what machine learning model I'm going to use and all of that.
And that's something important to say, because many times people try to think that, oh, the most important thing is just to choose the algorithm and go ahead with it. But well, you first need to get familiar with the data set, know the data, play with it, clean it. This is longer than we usually expect, but it's for the good reasons to choose the right algorithm afterwards.
Exploratory data is usually one of the most sort of like tiresome approach, but it's one of the most important steps because it gives you so much insight about your data set that like it would actually help you in determining what machine learning algorithm is. Actually helps you to better understand even the results of your machine learning algorithm. So because you always have to connect the dots, and like this step actually gives you a lot of information to how to actually connect the dots when you train a model. And also I want to, for example, look at the distribution of my numerical attributes. So let me actually run this one. Again, you can see it's pretty quick. It's almost in a second. So I can see, for example, the credit score distribution. I can see that the sort of around like 650, 680 is just sort of the credit score. What is the age? I can see that, okay, average is around like maybe like late 30s, around mid 40s. But again, I can see that we have customers who are around 80. And if you don't look at this one, and if you don't do the data analysis, you might think that, okay, anything beyond like 80, I might consider an outlier and drop that one. But then when you realize that, no, it's actually an age thing. So you may need to keep that because they're actually customers. So you might even see that, okay, maybe customers after a certain age, like above 13 age, like above 80, maybe there is some pattern behavior in customers above certain age. So this data analysis helps you to learn a lot. So we have also done that.
And also you can, I mean, for example, in this case, we don't have these crazy outliers, but sometimes you find data that is not good. You can find some person with 130 years, something like that, so you can visualize this immediately.
Yeah. So that's a very good point that Esma brought up. So if instead of like 80, it was like 140, I would have realized, okay, this is an outlier. This doesn't make sense. Like it's probably a mistake in, like, for example, data gathering process. But when it's like around 80, I don't consider that as an outlier. So this is actually very helpful in terms of like getting insight about your data. But one thing that you actually realize is that different features that we have, they're across different ranges. So for example, the credit score is from, let's say, like 0 to 800, ages like from 20 to 90 and all of that. So they're not on a sort of a standard normalized range. And sometimes that could be like, for example, like difficult for a machine learning model because there are different sort of scales. So what we can do, we can actually perform some feature engineering to kind of normalize that. So make sure like all of the features, for example, the credit score, the age score and all of that, they're falling into different in more or less the same range. So I can perform some feature engineering. So I'm going to define some new columns for like a 10-year for credit score by normalizing my already existing columns. So I'm going to perform some feature engineering. But again, as you can see that if we go to some categorical here, we see that we have some categorical feature, for example, like geography as well as gender, which are represented by sort of categorical variables. And again, for some machine learning algorithms, that's difficult to do. So you need to kind of convert this sort of categorical features to numerical features. And here again, it's where like Data Wrangler comes very handy. So again, we're going to go to Data Wrangler and we're going to perform some one-hot encoding. So again, I'm going to go to data. I'm going to do here. And then you see I have been doing some sort of data cleaning. Now I have different data sets I have, right? So I have df clean, like all of that. So I'm going to use df clean because that's sort of the data that I have clean. So I want to process on that one. So I'm going to select df cleans and then give it a few seconds. So it's going to load that. And then, okay, again, as I mentioned, I get a preview of my data. And there are many different operations you can do, find, replace, and format, and all of that. But one thing that I want to do, I want to go to formulas. I want to do one-hot encoding to convert my categorical features to numerical features. So I'm going to click on one-hot encoding, and then I'm going to select my target columns. So it's geography and gender. That's the columns that I want. And give it a few seconds. It's going to generate the code for me. So you can see that it imports like that, df clean, and it's going to create that one. And it also shows here the preview of that. And again, that's the only thing I want to do. So just one step. Can also like apply that one. I'm going to show that one. You can see that, okay. And then I can actually easily add that to my notebook. So I can go back that one, and then you can see that, okay, code generated by Data Wrangler for pandas data frame, df clean data, df clean one, and all of that. So it's actually generated that one. So I'm gonna run this one as well for one-hot encoding done. So now we are done. It seems to me that we have done a sort of a reasonable data cleaning and data engineering and basically one-hot encoding. So I think I'm relatively good in terms of moving to the next step. Is there any questions so far? Anything?
I think there is one question about the use of Smoothie, but I will probably do that when we go to the machine learning models part.
Okay, sure. Yeah. Okay, so one thing that you can see here, I'm creating data table to sort of save this. So I have a clean data. So I've cleaned the data and all of that. So now I want to actually save this one. You might question that, okay, why am I saving this to my lakehouse? So I'm actually saving this table data in a new table called df clean to my lakehouse, because later on when we actually train a machine learning model, I want to be able to, for example, compare the results of actual my data versus like the prediction. So I can actually like have a data in my lakehouse as a table, and I can import that. And later on, sometimes like you can, when you have your data saved in your lakehouse, like even if something happens above that, like you don't need to worry about that one. So you can already have your clean data in your lakehouse. So like even if something goes wrong with any of these, you forget or whatever, like your final clean data is already in your lakehouse, so you don't need to worry about that one.
One more reason also that is interesting to have your data saved as a table in your lakehouse is that it's available for the other data experiences in Fabric. Like if you want to see it with a data warehouse experience and do TSQL queries or whatever you want, this will be also something you can expose, and you can expose it even to Power BI and the Office tools also.
Yeah, great points. So we have done that. Again, you can see that I just saved it as a table to my lakehouse, and just kind of let's just review all we have learned so far before we move to next step, which is more exciting about training a machine learning model. So we have learned that, okay, we're having more customers from France, but we have also learned that like Spain has a lower churn rate compared to France and Germany. It seems most of our customers have credit cards. We can see that there are some customers whose age and credit scores are like above 60 and below 400, but we cannot necessarily consider them as outliers because that's a very realistic scenario. We have seen that very few customers have more than 12 bank products, and we see that customers who are not necessarily like active customers of the bank, they have a higher churn rate. So you see, these are the insights that you can get. And then you can see that, okay, what are the incentives I can have to have customers, like, for example, get more than one product of the bank. So then, like, for example, I can keep them for a longer period. So we gain some good insights from our data. Now we're getting to a more interesting part, which is basically training a machine learning model. So I assume there is no questions?
No, go ahead. We'll talk about that.
Great. So now I'm going to train a model, and I'm going to track my model. So to train a model, I'm going to use two machine learning algorithms, random forest from scikit-learn and LightGBM. I just need a few lines of code to train those models. And more important, I'm going to use MLflow and Fabric Autologging to track the experiments.
I just have to think. But probably I'm going to do this Smoothie question because we are getting close to that, and I don't want to forget it. The question was if Smoothie is a good choice for real time.
Depends on your scenario. There are like a Smoothie, I would say, is a relatively like sort of a simple approach, but there could even more advanced approaches. For sake of just showcasing this one, we chose like a Smoothie because it just shows that you can like do that. But yeah, depending on your use case, like you could even like choose more advanced one even for like real time. So it really depends on your use case.
Okay. And there is another question that is probably unrelated, but it's good that we mention also that there is a question about Copilot, that if Copilot would be available for PPU capacity. I really don't know, but should have some news about that, Amir, or no?
I am not sure about that one,
No.
but we can get back to you with more details about like if a
There is a blog post about the current pricing and everything of Copilot for at least for the data science Copilot. I can share the link. So and just to connect back, you were mentioning that now we are going to train the model and we are going to track this and we are going to do this with MLflow. So what is MLflow then?
Okay, great. That's a good point. So, if you're familiar with machine learning models, let's just talk basic. Is that when you train a model, like you select different parameters for your model. Like, machine learning models have so many different parameters. Okay, they're like which features you want to use. What are like in random forests, it's like, okay, what's the depth of the tree and all of that, right? Very traditional. You can like take pen and paper and write down, okay, this is my random forest model 1. I'm going to take these are the parameters I'm going to train. Okay, these are the metrics that I'm going to use. For example, I'm going to use accuracy, F1. So, traditionally, like you have to kind of like write down all of these to keep track of the models, because like it's barely the case that you just train one model and then you're happy with the performance. You have to train many different models, and even each model with different parameters, and then like compare across all of them to get a sense of, okay, which model is performing the best. Now, MLflow, we have already embedded in Fabric, allows you to actually automatically log all of these. So as you train a model, like an experiment, run an experiment, which is like one run of a machine learning model, it automatically log all of the parameters for your model, all of the metrics, the scoring metrics that you have defined for your model. So like once you train a model, you don't need to worry about like keeping track of them. You can just go to your experiment page, and then you can like look at all the models, compare the runs, and then you can say, okay, I can see that this model shows the best performance, so I'm going to pick that model. Does that answer your question, Ismail?
Oh, yeah, it's perfect.
Okay, great. So as you can see, so I mentioned that I've saved my data, my clean data, finalized data to my Lakehouse. So I'm going to read that data now from Lakehouse. Okay. Okay, 2 seconds. Now I have my data. So as I mentioned, we're going to use Fabric Autologging and MLflow to keep track of all the experiments that I'm running, log them and save the trained models. So, but for that, I need to kind of first import MLflow, which I'm importing. And I also need to select an experiment name. So which I've selected like sample bank churn experiment. So I'm going to run that cell again, done. So again, MLflow autologging capabilities are already extended to Fabric. It automatically captures the values of input parameters, output metrics of a machine learning model. And I think that there should be a link in the chat that actually provides you more information about like what are the exact autologging capabilities that we have in Fabric. Okay, I'm gonna like set up my MLflow experiment running, and then so that's it. I also use data stamp to append to experiment and all of that. So now the more important part, okay, we want to actually train. So I need to import some of the machine learning library models. I'm gonna import from scikit-learn and LightGBM, and I'm gonna import the metrics that I want to kind of use to evaluate the model. So I'm gonna from scikit-learn, I'm gonna use a random forest, and from LGBM, I'm gonna use LGBM classifier, and then different metrics, accuracy score, F1, precision, different metrics that I want. So I'm gonna run that one. So I'm going to import all of these libraries. Okay, done pretty quickly. Now, in any machine learning problem, you need to split your data to training and test data sets, right? So you want to have a training that you train your machine learning model, and then you want to test your machine learning model on the test data. You can treat the test data as unseen data. It's a data that like unseen. You don't do anything until like you have finalized your model. You want to test it like how your model is performing. So again, I'm going to use the train test split from scikit-learn to kind of split my data to training and test. Now, the question that has come about the smooth, and like, in the beginning, we talked that, okay, we need to install this custom library because our data set is like imbalanced and all of that. So now we want to apply smooth to my training data. One point that I want to make that is that you only apply smooth to your training data, and you're not your test data. The test data you're gonna treat it as your unseen data. So you're going to apply smooth to your training data. So basically, you want to generate some sort of a synthetic new samples. So you kind of create some balance to your data, because if you remember initially, it was 80% versus 20%. 20% have left the bank, 80% has stayed with the bank. So you want to create some synthetic samples to kind of balance this one, so you can help your machine learning model to better learn the decision boundary. So again, you can see that from MLflow custom library that we install, I'm going to import a smooth, and then I'm going to apply smooth only to my training data. So it will take a few seconds to kind of apply that one. Done. So I applied that one. And now we are actually getting to the model training. So as I mentioned, we're going to train 3 different models, 2 random forests with different parameters, and 1 LightGBM. So for the first random forest, I'm going to pick a depth of 4 with 4 features. And this is the name that I'm going to select for random forest. Random forest C1, SM, and SM is basically referring to like it's going to use smooth for like its balanced data set. So I'm going to train that one. And let's see how long it takes. So far, any questions as we are waiting for this run to finish?
Not so far. I mean, I think something we can mention at this moment is that, well, when we are logging these runs with MLflow, we are logging the hyperparameters that we use to configure the models, but also we are logging these metrics of the execution, no? So
exactly. So if you look at like here, I'm already like calling MLflow, and this is going to be saved under that experiment name, under this model name, like RFC1. So it's going to be sort of all of the model parameters and the metrics are going to be saved in my workspace. And you see it's finished now, and you can also see that RFC1 SM, the name that I selected for my model, is already like saved. I can actually click on this one, and then it takes me to my workspace experiment. So you can see that sample bank churn example, that was the experiment that we set up. And this is you can see that RFCC1. So you see that 9:46 a.m. probably 2 minutes ago. So it shows basically the parameters. It's all run metrics. You see, it shows different parameters and all of that. So we got that one. Now we're going back to our sample again. Now I'm going to train another random forest with different parameters. It's like a maximum depth of 8 and 6 features. So let's run this one. Now you can see that for this one, I've selected a different model name, which is RFC2_SM. And that one also we're going to be using MLflow. It's going to also be logged and saved to my workspace as a model. So you can see that that's happened the same. RFC2, and finally I'm going to train an LGBM, and these are the parameters that I have set up for my LGBM, delta sum of 2, then 100 estimators and all of that. So I'm going to train that one as well.
One thing also that, I mean, we don't show this in this presentation, but you also, with the run, you also log, let's say, somehow your dependencies and all your environment, so you can reproduce these experiments. I mean, what we're trying to do here is create a log of every run we do, the right parameters we put, the right libraries. All of this is stored in this.
Yeah, that's a good point. So now you can see that I have some sort of a log of all of my model that I have trained, the learning rate, the maximum depth, and all of that. And it kind of shows everything to me. So I can basically get a good sense of like how my model is performing and all of that. And then again, for all of it. So RFC1, RFC2, and like that. And also, like you see that it also showed me the feature importance. So you can see that, okay, what feature seems to be more important and all of that. It also like show me a sort of a visualization of the importance of the features in terms of how my LightGBM model is doing. So it basically shows everything, and then like all of that. So you can get a lot of stuff. You see like all the dependencies, like you learn a lot and gain a lot by looking into your like saved models after you train a model. There's so much information that helps you a lot with your model, and then you can do that for all of them. So you can see that even like for ML model, and you see we can do it for all of your models. Everything is logged, you can access them, so you don't need to worry about like losing track of everything. As you train a model, every model is going to be saved into your workspace, into your experiment track, and then you can easily compare them and then select the best model that you have. So now we have trained 3 models, and then you can see that as I was just showing, all of the model, LightGBM, all of them. And as you can see, this is a screenshot from different runs that you have. Like you can see all of them are basically going to be logged here. So then you can basically like track which model that you want. For example, you can say, okay, this model has an accuracy of like 86%, the other one has 80%. So this shows a better performance. So I can select that one. So easily you can go to your workspace, you can select the workspace experiment name, which in this case is bank churn experiment. And then you can get the logs for all of your models. Any questions so far? Anything that?
Not so far, I think. I'm just double checking. No, all good.
Okay, great. So now we have basically, we have trained a model. We can now save the model. So we're going to basically, we train 3 models. Now we can save them to 2 different models. So RFC1, RFC2, and RFZ. Like, so we are going to save these models because now we're going to apply these saved models to our test data set and see how they perform on the test data set. As I said, test data set is sort of an unseen data set. When you train a model, you want to see like how they're performing on test data set. So you can actually like perform. Actually, I forgot to run this one. Sorry. So you're going to save these models. Okay. Pretty quickly, less than probably like, yeah, done. Now I'm going to assess the performance of these saved models, the 3 models that train on my test data set. So I'm going to all the 3 models on my test set. So I get now some predictions. Now I want to basically look at the predictions on my test data set, and I'm going to use confusion matrix. Confusion matrix is a sort of popular metric that kind of shows the true and false positive negatives, and then we can see that for all the 3 models. So I can write the code for kind of show me the confusion matrix. This is basic to kind of plot the confusion matrix. So now I'm going to show the confusion matrix for my first random forest model, which is this one. Okay, so I get some sense of okay how it's doing in terms of like the total number of like false positive, false negative, true positive. I'm also gonna do it for my second random forest with like depth of 8 and 6 features, and finally I'm gonna do it for my LightGBM. So I've trained a model, I save my models, I tested my saved models on my test data set, and now I'm plotting the confusion matrix to see that which model is performing the best on my test data set. So I've realized that, for instance, LightGBM is doing the best, so I'm going to select LightGBM as the best model. I can also save the predictions from all of the models. So I can save the prediction from all the 3 models as tables. So I can also, like you can see that here, I'm saving all of the results. So I'm going to save the results again to my lakehouse. So now I have the prediction results as well in my lakehouse. So let's summarize what we have done. We got our data, we clean the data, perform exploratory data analysis, use data wrangler for like one-hot encoding and cleaning. I split the data to train and test the splits. I sort of applied the smooth for like class imbalance issue, and then I trained 3 different models, and then I assessed the performance of the different models on my test data set, and then I also saved the final prediction results into my lakehouse. Any questions so far?
Yes, there is a new question. This what's the big difference between using Power BI and using Jupyter Notebook instead?
Do you want to answer that question?
Yeah, no, of course. I mean, one thing is that, well, Power BI is been historically a tool like for users who like to do graphical things and more data analysts with a different set of skills, let's say. So that's one difference. Like that, obviously, notebooks are like a more general level kind of tool, but you require programming to be able to do things. Well, now you can generate things, obviously, with Data Wrangler, with Copilot. We're making this easier, let's say, democratizing this. So things are getting closer. On the other hand, Power BI also does not have some support for some of these advanced graphs that you can produce in notebooks. But you can also integrate it easily with all of the other tools in the Microsoft ecosystem and others, through connectors that get data in, data sources, and all of this. So, yeah, I mean, both tools are different and don't they are not for the same audience, let's say, but they have, of course, a good intersection of features,
Yeah. And not related to this notebook and this demo, we also have we have a feature called like semantic link. that actually allows you that if you have a data set in Power BI, you can actually like bring your data from Power BI data set to Python and to Fabric Notebook. Which is out of the scope of this sample, but we can also share notes about what that feature is.
It's great that you mentioned that one, because I have to record that video this week, so you will be seeing soon in the Power BI channel.
Great. Yeah, that was a good reminder then. So as I mentioned, one of the challenges that we have usually with machine learning or like data science problems is that like everything kind of ends at like training a model. And so, okay, what is next? So the next key is that actually like translate those insights from like ML model training and like data science to actually business intelligence with Power BI. So there's like detailed instructions on how you can do that, but like basically you can like the predictions that you have made like using training a machine learning model. Again, I think the best predictions came from the LightGBM. You can like you have saved the data in your lake house, and now you can basically import it to like Power BI and basically create a Power BI report and look at it and say like, how does my prediction looks like? So for example, shows that customers who have like more than 12 the bank customers have a higher churn rate. So you can see that, for instance, like Germany seems to have we predict that Germany has a higher sort of churn rate compared to the other two, France and Spain. So this is an indication that like, okay, maybe there is more competitive banks in Germany that offer better sort of services to customers. So maybe we need to look into how can we improve our services in Germany. Like, okay, we can also look at, for example, like a churn rate across a credit score. So we can see that the credit scores that kind of lower, they may, like, for example, have a higher churn rate. So like, how can we have incentives for our customers with lower churn rate to still stay with the bank? So these are the insights that you can get, and it can like basically help the decision makers and like business analysts to actually take actions that actually help the business. And then finally, I think, let me just run this one to kind of show that. Obviously, it kind of takes 2,000 seconds, but it was because we are pausing. But generally, if you run it all together, it takes it's very quick to run the notebooks on Fabric. Sort of that wraps up the sample. So back to Ismail.
Yeah, just one thing. We have one more question, and this is this question is why to do data preparation if it's easy. I'm sorry. I think data preparation is easy in Power Query and Dataflow, so why use Python? And I want to answer that one because one thing is that Python is a general language tool. Like you can use it even outside of Microsoft, for example. That's one reason. Like you can use it in Visual Studio Code. You are less tied to a product. That's one advantage. But a bigger advantage is that all these libraries, like PySpark, have been optimized also to run at scale. So if you have a lot of data, well, you will probably struggle to do that with Power BI, but you won't struggle for sure to do it with the data science experience, like with notebooks. So that's another reason.
And one thing I may add is that also like different personas, for like data scientists, maybe like Power BI is more challenging, but for like Power BI sort of experts, it's easier for that. So like, for data science, I think maybe like Python is a little easier, but that's also like a personal choice.
But something that's cool of these questions today is that they shows how we are getting closer. And this is probably something that the product wants, that Fabric wants, that democratize this, that everybody can do a little bit of those. And as come as you are is more or less the dilemma, no? Like with your skills, with your tools, and do the work that you want to do, the data processing tasks, let's say. Okay, so well, let's go back to the slides then. Okay, so we followed this module, and this is, let's say, one of the key scenarios we have for data science in Fabric. So you will find in this link, that is not the same link we shared before, you will find a more detailed step-to-step explanation of this, like exactly what Amir did, but well, with a screenshot of each step that you can follow along. So don't hesitate if you couldn't follow for any reason, or you want just to repeat and go deeper. Well, don't hesitate to do it on your own, going through this link. So now with this, well, we are in the we only have one more session to come. That is next Thursday, and then there we will wrap the whole series. And when we explain you how to submit your projects that you're building into this sort of virtual hackathon, to participate and earn the prizes for the Fabric Community Conference. No, so that's next Thursday. No, don't miss it. And also, well, we want to mention that, well, we are running this Fabric community that you can join if you have more questions that somehow you didn't get answered, or you want to continue the discussion. Don't hesitate to go there. Well, we are growing. We are always looking at these. Bring your feedback also for the product. If you think that there is an interesting example, well, tell it to Amir maybe in the forum. So we follow along. So we are listening to you. And one other thing is that we released not long time ago this Fabric Community Career Hub. The idea here is that, well, if you are a specialist on some of these, for example, workloads like Power BI, but you want to learn more about other, well, this is the opportunity to grow your career, learn more, and especially to prepare yourself for the certification. We are really, let's say, bringing a lot of support for the DP600 certification. That is the first Fabric certification that is going to be released soon. I mean, it's already in beta status, and soon it will be like a definitive status. So don't hesitate to go there also to learn more. And this is the last thing. Well, don't in many of the questions, for example, the one about Copilot are about what is coming, no? And we always want to know what is coming in the roadmap. So don't hesitate to click this link, and you will find way more resources to learn what is already there and learn what is coming, what are the new features, and go ahead with more. I think with this, we close the session. So thank you, everyone. Thank you, Amir, also.
My pleasure. Glad to be joining Ismail too for this presentation. And again, as Ismail mentioned, please always send your feedback. We're always happy to address and improve our samples.
Yep. Excellent.